Lou Del Monte, and welcome to Del Monte on Science. Today we're going to talk about M-theory, and we're going to talk about it in the context of how does M-theory create universes. So let's start by discussing M-theory itself. Alright, well basically M-theory stands for, the M stands for membrane. And so what M-theory, and we talked about this a little bit in some prior videos when we talked about the Dirac-C in the videos Something from Nothing. The Dirac-C being that empty space consists of positrons and electrons, matter and antimatter, and we talked about M-theory when we asked the question, well, if a vacuum contains this energy, and this has been proven to be the case, then we ask the question, where is it? Because we don't see it in the normal 4 dimensions of height, width, length, and time. We don't see any energy, any particles. And we said, well, where is it? And one of the potentials is it's in the hidden dimensions of M-theory. M-theory actually has 11 dimensions, as opposed to Euclidean geometry, which considers 3 dimensions, and Einstein's space-time geometry, which considers 4 dimensions. What I'll be talking to today regarding M-theory is from my new book, Unraveling the Universe's Mysteries. And you will be able to get this book on Amazon.com or BarnesandNoble.com online. So please avail yourself of a copy. I think you'll find it extremely fascinating. Going on with M-theory, we're talking about 11 dimensions. So M-theory is a mathematical formulation, and I'm going to get to the fundamentals, but the big deal about it is it postulates 11 dimensions. So 11 dimensions. Now, what is M-theory? All right, so let's answer that question. What is M-theory? Actually, we have to go back a bit. Back to, well, roughly the classical view of the atom. So if we start with the classical view of the atom consisted of electrons and protons and neutrons, etc. And that was one view of reality. In about the 1960s, so this view of the atom was prevalent during the early part of the 1900s. Okay, and during the 1960s, they found out that the atom was not; these were not the only subatomic particles. They found many additional subatomic particles. Such as neutrinos and so on. So they found more subatomic particles. And this culminated, this finding of subatomic particles, culminating in finding a quark. Quarks, there are 6 kinds. And so it's quarks. And this is considered the most elementary particle. And so that in the 60s and 70s, we get the whole point that there are quarks. Okay, so you would think this would end the story, but actually what happens in the 1980s, along comes string theory. And what this postulates is that all reality consists of one-dimensional vibrating strings. So you have, and I'm going to have to draw it in 2 dimensions because it's not possible to draw a one-dimensional vibrating string. But you have a string, and it's vibrating, and the way it vibrates actually determines what you perceive in reality. So string theory is postulating that all reality is made up of these one-dimensional vibrating strings. So now and in addition to these one-dimensional vibrating strings, it postulates that there are 11 dimensions. All right, now in the 80s, this went on. A number of string theories were developed. As a matter of fact, by the about mid-90s, we had 5 different string theories. So we have 5 different string theories, and they all appeared valid. And this caused a lot of concern among scientists who said, well, look, these can't all be valid. There's something odd to have 5 different theories all being valid that supposedly represent reality. So along came Edward Witten, I should say Witten, W-I-T-T-E-N, and in 1995 he ties all the string theories together, if you'll pardon the pun, and he comes up with M theory, which is like a superstring theory, and he shows that the 5 string theories are just special cases of M theory. So now we have one unified theory of all of the string theories. Now, at the beginning of this video, I mentioned that we were going to look at M theory in the context of it being a multiverse. According to M theory, there are membranes, 2-dimensional membranes, and that's what the M stands for, membranes, that exist, and they exist in an 11-dimensional space. And when 2 membranes, this is the theory, when 2 membranes touch or collide, this collision forms a new universe. Now the brain itself is considered a universe. So in theory, we humans live on that universe, and that conceivably there could be other universes. That's what M theory is telling us, and that when they collide, this forms a new universe, and this is what we perceived as the Big Bang. That's the new universe that created our universe. All right, so where does this leave us? All right, there's a lot of criticism levied at M theory. And the first is that although mathematically it's very elegant, and some prominent, well-respected physicists like Stephen Hawking, Michio Kaku, etc., have considered this as, especially Stephen Hawking, has considered this a theory of everything. It actually does not address some very fundamental questions. The first problem that physicists have with this is that it's not provable. We are unable to see these one-dimensional vibrating strings. We are unable to see the membranes. We are unable to prove that when membranes collide, they create new universes. We have a theory that's being postulated to explain some of the issues associated with the Big Bang. That doesn't mean it's wrong, because the 11 dimensions of M theory turn out to do help us understand other issues that we are facing. For example, when we ask where are the virtual particles in a vacuum, or where is the energy in a vacuum, they could well be within one of the dimensions of M theory that we don't normally experience. So there are a lot of opponents to this theory. I suggest open-mindedness, because I think it does help us explain some things. The biggest failing of this theory, in my opinion, and I think of even the Big Bang theory, is it does not explain where the energy, the origin of the energy, and that's the one that I come back to over and over again. Whether you look at the Big Bang, and I've talked about the Big Bang duality theory in my videos, and Krauss has talked about, Lawrence Krauss out of Arizona University has talked about the Big Bang being the result of a virtual particle in a super universe. I've talked about it being a particle pair, matter and antimatter, and that collision causing the Big Bang. But the basic issue is, where does all this energy come from? You know, where do we get the energy to create membranes? So that when they collide, they can create a new universe. And that continues to be the big issue in the multiverse theories and in the entire theory of the universe. Whether we look at the Big Bang, which is the most accepted theory of physics, it still does not explain, even when we talk about it being created by virtual particles in a super universe, etc. If you go back to some of my early videos, it still does not explain where does the energy come from. So that's the big mystery. So with that, this overview, I hope you've gotten an appreciation of M theory, and I want to thank you for joining me in this series.